all that hammer.
So I appreciated you all waiting for me to come back to do this very important job of introducing Sean McLaughlin. He couldn't have done it without me, I can tell. But Sean comes to us from GreenHeck. GreenHeck and GreenHeck University have been real supporters of content for this program for a long time. John Longden is one of our associate partners from Viron. He put all this together for us. So really excited to have Sean and his group continue to provide education for us. And I guess I'll turn it to you, right? We've kind of modified our presentation a little on this as well, and you'll talk to us all things dampers.
Yeah. So we're going to focus on life safety dampers as well as some, and then touch on some heavy duty stuff as well. I really want to get more structured in that on the life safety dampers because it's it's life safety, right? It's UL rated product. And then when we get kind of the heavy duty side of things, I want to make more of a dialogue discussion with you guys. Get some introduction to that side of things too. So it's a little bit of a kind of a two-sided presentation. I'm going to try to rip through this relatively quick because I'm going to cover quite a bit of information, especially on the life safety side of things. So any questions, feel free just to interrupt me because I'm just going to keep ripping through this quick. So my name is Sean McLaughlin. I'm an application engineering specialist in the commercial damper department. My focus is going to be on air measuring and balancing, as well as life safety and electric duct heaters for the GreenHeck group side of things. So today I want to go through life safety damper product, the different types of life safety dampers, go through the damper rating and requirements. So there's a little bit of some confusion there sometimes. So touch on that with IBC and UL and how they define that. Understand some installation requirements and some different options to help on installation, as well as available option accessories, and then really go through and touch on the testing and maintenance requirements and how that relates to fire and smoke dampers. So the big codes and standards. So IBC, NFPA, and UL are kind of the big hitters on life safety damper product. There's a lot of confusion. It's kind of that who's on first situation where nobody really knows who's calling on what and what's the requirements for what product. So you got a lot of fingers pointing back and forth. Hopefully I can get a little bit more clear on who's dictating what on life safety dampers. So like I said, IBC, NFPA, and UL are going to be the big ones. IFC jumps in there too, and then there's IMC on there a little bit too. But like I said, the three big hitters is one I'm going to be really focusing on there as well. Taking a step back, what is required element of some approved life safety damper installations? This seems like a pretty elementary thing, but the big thing here is you need three things, and the big one is the rated barrier. So you need to have a barrier that is a rated life safety barrier, and it fulfills all the obligations of what a rated barrier needs to be. So we get a lot of questions. Hey, can I install this damper in this type of barrier? Our answer is it a rated UL barrier? Is it going to be a fire rated barrier? Can I install dampers in doors? No, that's not a rated barrier. Even if it's a fire door, can't have a damper in it. Big thing is listed product. That kind of goes to the rated barrier. The product needs to be tested in the barriers that it's being installed in. So what needs to be done is the installation requirements need to be followed. So the wall needs to be framed out correctly. The angular space requirements need to be met, and the retaining angle and all of those options need to be used there as well. All right, so jumping into building code, what does IBC dictate for dampers? So majority of everything for the IBC for fire smoke dampers is all going to be in Chapter 7, Section 717. The big thing that IBC is going to say, and they're going to point to, like I said, the finger pointing thing, they're going to say, hey, the damper needs to be installed per the UL guidelines and per the manufacturer's instructions. Then the big thing that they start doing is defining where dampers need to be used. So each section or each subsection is going to go through where you need to have firewalls, fire barriers, shaft enclosures, fire penetrations, anything that's going to be the IBC's job is here's where you need to have dampers. So you're also going to see things, where you have exclusions to dampers. So you have 1 hour rated barrier in a building with sprinklers. There you go, nailed it. With sprinklers, don't need a damper. That's IBC's job. That's where they're gonna dictate what the codes and where dampers need to go. NFPA. What is NFPA gonna do for UL rated dampers and products for life safety stuff? They kind of dip their toes in a little bit of everything, but a lot of it, what they're gonna do is testing and maintenance. So NFPA standards 80, 105, 90A, and 92 are gonna be mainly all gonna be where the life safety dampers are gonna be. 90B is being phased out, so in 2015 and beyond, if your municipality is using that particular standards, then you're not going to see anything with 90B. But if you're using older stuff, 90B will have some in the for fire smoke dampers in there as well. So big thing with NFPA is testing and maintenance. That's where a lot of that, and you're going to see actually UL point their finger at NFPA for field testing and maintenance. So, for example, big one we get is, hey, I have a fire smoke damper, I need to change the actuator. Can I do that? Yeah, you can, because NFPA says you can as a field service requirement. It doesn't need to be, in NFPA's words exactly, is it has to be like or better. So, and UL just says NFPA dictates that. All right, what is UL? Underwriter's Laboratory. UL 555 is going to be your standard for fire dampers, 555S for your smoke dampers, and UL 555C. What UL does is the testing and certification that a damper will perform in a particular fire barrier. With the UL follow-up service, what you can do is you can make a modification to a damper, to a fire smoke damper, and as long as it meets and the way that damper would have been built from the factory, you can make that modification. So you come to us and say, hey, I have, XYZ issue, or I need to go from external to internal mounting of an actuator. You can do that because it's a factory option. We actually do have an IOM and parts kits to do that, make that modification change. If it needs, if the AHJ says, I need UL put their stamp on it, UL can come out and put their stamp on it. It's going to cost you $3 to $5 grand, but it's something that can be done. So purposes of life safety dampers, obviously the big one is going to be containment. So this is the building codes are going to require them to protect penetrations of buildings and obviously of barriers in rated construction. And another big thing is engineered smoke control systems. So the number one casualty in building structure fires for people isn't going to be necessarily immolation. It's going to be asphyxiation by smoke. So with engineered control smoke systems, they're often combined together to be used in compartmentalization to control smoke on buildings. All right, let's dig a little more into fire dampers. UL 555, kind of beating this a bit, or beating this like it. I can't talk today apparently. All right, so just protecting that penetration is the big thing. All right, touched on this a little bit before in the beginning here. Hourly fire resistance rating. So IBC and UL have this long-standing disagreement on what needs to be used when in terms of notation. So you'll see UL hour-and-a-half rated, UL 3-hour rated product, and then you'll see building plans and specified they need to be 2-hour assemblies, as 3-hour assembly, and 4-hour assemblies. What does that actually mean? How do they jive? This is exactly how they jive. The IBC 717 subsection 3. This table will show you that if it's less than a 3-hour fire rated assembly, so if it's a 2 or 1 hour rated assembly, you only use an hour-and-a-half rated damper, a UL hour-and-a-half rated damper. And if it is a 3-hour or greater, including a 4-hour assembly, is a UL 4-hour rated damper, or excuse me, UL 3-hour. Man, struggling. Apologize. All right. So I'm not really sure why the audio is not coming through, but long story short, as part of the UL testing, we at GreenHeck, we have a UL and AMCA accredited lab, and we actually do our own fire testing in-house. So part of that fire testing is what we'll do is we'll put a damper onto a bulkhead and put it onto a furnace, and then heat that thing up to about 1900 degrees. And you'll see that here shortly. And that galvanizing makes a nice little glow. So it's at that current point, it's about 1877 degrees for that particular fire test. So part of this test is obviously going to be, making sure that the damper can survive during a heat element. Then there's also other part of this test is the hose impact side of things. So we'll see that shortly where they have a real specific pathing and there's a certain pressure that the hose needs to hit. So it's like if it were, fire hose were to hit the barrier, and making sure that that damper holds up to that. The really strict pass-fail requirements for this. At the end of the test, if there's more than an 1/8 inch through hole, so they had to take a threaded rod and they poke and prod the damper. If there's more than an 1/8 inch through hole on the damper anywhere, it fails. So you can imagine how many opportunities for failure there with the damper with that many blades. But it's something that all of our dampers are tested to. So this is the hose stream test. One thing I find absolutely funny is you can tell the GreenHeck employees are all wearing their Martian suits, and then the UL guy is no PPE at all. So you can tell where the UL stands on PPE on that side of things too. So this is the hose impact test, and it's a very specific pressure that the hose needs to be pressured at, and it's a specific time for the damper as well. So he's looking at, just giving an initial assessment, but making sure there's no 1/8 inch through holes. And like I said, they go through the damper on the assessment side of things and go through and really poke and prod through on that. So that gives you an idea. And after UL fire smoke tests, I think on our size furnace, it's about $6,000 of gas to run that furnace for that UL test. So it gives you an idea of how many BTUs that the thing's putting out. All right, so some part of the UL marking application guide here's 2 types of fire dampers are there for static and dynamic applications. Static dampers are going to be used in systems where the air handling unit or fan is shut down completely during an event of a fire. Dynamic is going to be used in an application where the fans can be still running. There's airflow during a fire incident. Our recommendation is always use a dynamic. That was what we recommend. From a cost standpoint, you're talking a few bucks because you cannot use a static damper in a dynamic situation. You can always use a dynamic in a static situation. So for the couple extra bucks, save yourself a headache, get a dynamic damper. And I mean, we're literally talking a couple of bucks. It's not like we're talking 30, 40 bucks a damper. It's a couple of bucks a damper. All right, fusible links. This is a topic that comes up every year, this time of year. Nuisance tripping is a big one. So IBC requires 160-degree minimum fusible link temperature. Standard is in the industry is 165. And 212 degrees is going to be our max for static dampers, and what we would recommend at GreenHeck is just a basis of design. The reason for that is nuisance tripping, and IBC and UL both agree, not exactly, that the fusible link has to melt at 165, but a fusible link doesn't need to melt at 165 if it's labeled at 165. If you give us a call and say, hey, I got a damper next to a furnace and it's nuisance tripping, it keeps failing, but my duct temperature is only 130 degrees. Yep, that fusible link's working perfectly fine. So you have a 50-degree temperature difference between what the fusible link says on it and what it actually can melt at. So 115 degrees, and it's okay for UL and IBC. They have, one says 30, one says 50, but they don't agree on everything, but that's fine. But it does say that, hey, these fusible links need to melt at those temperatures, but they're not going to for the most part. They're going to melt at a lower temperature. So like I said, 212 is where we like to recommend for anything, especially as near air handlers or furnaces and things that could make a little more temperature or heat. We do have options for 286, and then 350 degrees is the maximum for any dynamic application. So that includes, you know, your standard dynamic fire dampers as well, fire smoke dampers. All right, velocity and pressure ratings for dynamic fire dampers. So minimum is 2,000 feet per minute at 4 inches of pressure per UL. You can jump up in velocity and pressure at 1,000 feet per minute increments and 2-inch increments for operational testing for UL. So what that means is that you could theoretically have a 5,000 feet per minute at 10-inch rated damper. It doesn't exist really from an industry standpoint, but the testing protocols are there to do it. So we do see applications for that moving forward. If you're looking for a product offering, it's going to be rated at 2,000 feet per minute at 4 inches. This is sort of where the industry is kind of, coming at. Damper construction, obviously you kind of touched on this a little bit, but two common construction types are going to be our curtain and multi-blade. Big thing with the curtains, obviously, is it's going to be the low-cost option, and it's going to be, your thinnest profile option. The multi-blades are going to be all from a green hex side of things are going to be all dynamically rated. I don't know of any competitors that have a static any longer that is a multi-blade. Big advantage is you're going to be a little larger sizes than your curtain dampers. Also, with all of our options, they do double as a balancing damper as well. So they all have manual quadrants on them, so you can reduce the amount of balancing dampers you have in your system by integrating a multi-blade fire damper in partitions that would require it. All right, big thing also is material. We do have galvanized 304 and 316 stainless options. We do not have any aluminum models. Aluminum melts at 1,200 degrees. Fire testing goes up to 1,900 as a minimum. So if you want to puddle in your fire barrier, I don't think your building owner would appreciate that. Quick talk about transitions on fire dampers. Type A and Type B are going to be the most common that we're going to see from a manufacturing side of things. Type B is going to have the blade stack out of the airstream for the curtain fire dampers. Type C is CO, and Type CR are going to have 100% free area transitions, and then your Type R is going to have a high free area, but you're still going to have some of the blade stack in the opening for your rounds transitions. We do offer true round life safety dampers, and it is becoming a more popular option. The big thing that we like to point out is the openings in the wall don't have to be round, and if it's a framed the stud wall, it shouldn't be a round opening actually. The retaining plate will cover the square openings in that. So if you have round ductwork and you don't want to use a transition, less expensive to go to a true round, and you don't need a round hole in it. So, all right, going over some of the installation side of things. Mounting orientations on curtain dampers matter. So from the factory, you do have to pay attention on what the orientation says for the damper. The curtain dampers are going to be listed with this side up. What happens is we always hear, and we hear this quite often, is that I can use a horizontal and a vertical application. Sometimes, yeah. But when you have these different ratings, so you have these different velocity ratings, different pressure ratings, and even the size will dictate how that damper is going to be constructed. So in green heck dampers, for example, we have 6 different ramps, which are the portion that the blade catches into when the damper's closed. So when you guys are having issues pulling those dampers open sometimes, that they're stuck in those ramps. And then we also have 6 different springs that are used. So depending on the pressure, the velocity, and the size of the damper, and the orientation will dictate which of those 6 are picked. So there are some combinations where, yes, the vertical and the horizontal are the same, but not all the time. And the reason I point that out is we always get that phone calls, hey, can we swap this damper over and around? No, is the main answer. Like I said, there are some crossover, but it's not universal. All right, multi-blade orientations on multi-blade dampers. These you can use, in most cases, swap them around. Sizing is the only thing that matters. Construction doesn't change depending on horizontal and vertical, but the only thing that would dictate it for the most part is going to be the size. So we have a wider offering on the horizontal than we do on vertical fire dampers there. The only other thing is making sure that the blades are always going to be horizontal. They don't run vertical. So if it's not tested as a vertical bladed model, and there's actually thrust washers that are actually between the blades and the jam steel, so they don't get eaten up. They don't get just totally deteriorated. Big thing there is just making sure that the damper blades are horizontal, unless it's a vertical blade model specifically. There's another big one is, if you look at our IOM or any other competitor, they have, multi-blade or excuse me, multi-section assembly sizes, max and minimum. And you can see there. The big thing is the dampers must be ordered to fill the full opening. So you can't take multiple damper sections, stick them together and put them in an opening unless they were ordered together as one assembly. Cool. All right. Message from my boss. All right. So where was I? Okay, horizontal installations on fire smoke dampers. There are two exceptions, but this happens all the time as well. Is they can only be installed horizontally in concrete floors. The two exceptions are going to be tunnel corridor CFSDs and I-503 are going to be the two exceptions. So tunnel corridor ceiling dampers, you can see you've got a very specific use case there for the CFSD usage. And I-503, we'll go into that a little bit more. It's something that we pioneered around, I would say, 2015 or so, or 16, as a horizontal non-load bearings to use on shaft openings as well. So jumping into that a little bit more, I-503. Like I said, it's a great thing. Actually, I think I have a good video here. Yeah, hopefully the audio.
Section 713 in the International Building Code addresses the provisions that apply to shafts required to protect openings and penetrations through floor ceiling and roof ceiling assembly. Subsection 11 addresses the shafts that do not extend to the bottom of the building or structure. Fire-rated shafts enclose a space extending through one or more stories of building, connecting vertical openings in successive floors or floors and roof. One of the more difficult tasks facing designers, contractors, and inspectors when working with the shaft penetrated by a duct is protecting the horizontal opening at the bottom of the rated shaft. There are three typical methods used to enclose the bottom of the shaft when it does not extend to the bottom of the building or structure. The first method is to enclose the bottom of the shaft with the fire-resistant rating construction that is equal to the rating of the lowest floor penetrated, but not less than the rating required for the shaft enclosure. It is important to know when a shaft is enclosed at the bottom with fire-resistant rating construction, it is required that the assembly has passed the fire test in a horizontal position, and any penetrations in the shaft be protected per applicable building codes. Duct penetrations can then be protected with vertically mounted fire smoke dampers. The second method is to terminate the shaft in a room, which has the same purpose of the shaft, and separate that room from the remainder of the building with construction equal to the fire-resistant rating of the shaft. Duct penetrations can then be protected with vertically mounted fire smoke dampers. The third method is to protect the opening at the bottom of the shaft using Greeneck's new 2R fire-rated floor ceiling design. UL fire-resistant design number I-503 is the first and only UL-listed floor ceiling design made from steel studs and gypsum board that is approved with damper penetration. Only Greeneck's EFD, FD, and FSD series dampers are approved to be used in this innovative design. This installation method results in more usable space for the owner, more flexibility for the design professional, and reduces installation time for the contractor. Please contact your local Greeneck representative for more information about the industry-leading fire smoke damper installation method. Greeneck will continue to lead the industry in new, innovative damper products and solutions.
So long story short, that's, we actually kept that design open. So now all the competitors are using that design as well. We didn't want to create a similar situation where you see with CRDs. I'm sure you guys are familiar with the headache that some of the designs and things that CRDs can cause. So we kept the design open so that competitors could get in on the design too and use that same. So from a building specification and just ease of use for the industry, it's all going to be I-503. So I think in the video it said, I think that video was made in 2016 where it was only DFD, FD, and that's not really true anymore. I know our competitors are also tested and approved in I-503 as well now. So that's there. On there, like I said, it's all about finding easier solutions for the customers. Some general requirements for installation of fire and fire smoke dampers. Big thing I like to point out is that if you have combustible assembly, so if you have wood studs, you have to line the entire opening with your gypsum. Steel stud is actually not required and actually not tested in that. So while it's not going to hurt on that side of things, from a strict testing standpoint, a steel stud lined wall with gypsum is actually not part of the design. Other thing is double vertical studs required for dampers over 36 by 36 on those installations. All right. Traditional, this would be 2 retaining angle installations of fire dampers. The center line of the damper frame must be in the plane of the wall. So it doesn't have to be in the center of the wall or anything like that. So you can actually have the blades of a damper outside of a wall. It's just as long as the center line of that damper is in that wall somewhere, you're good to go. Angular space requirement is required for the wall opening and the damper sleeve. And the retaining angles must not be fastened to the wall. So you have 2 retaining angles, the damper is going to be floating within that opening, and it should not be fastened to the barrier at all. Breakaway connections. So breakaway connections, there's 3 options for that. You got your transverse joints, your manufactured flange systems, your TDCs and TDF, flange connections. Big thing there is just making sure that the sleeve, or excuse me, the ductwork can break away from the sleeve in the event of building collapse. Hopefully that fire rated wall is meets the requirements of going floor to ceiling and where this from this part. But if the building were to start collapsing around it, you want to make sure that your damper stays in that barrier and protects that opening. Part of that testing. It's super scientific. What we do is we actually take a telehandler, take a 55-gallon drum filled with cement, and then drop it on a patch of ductwork. So what this is test is make sure the breakaway connection is going to work. It's an approved breakaway connection. The other thing is making sure that the retaining angles are going to be something that's going to hold the damper in there. We'll talk a little bit more about that as well. But like I said, it's probably one of the most scientific tests we do at our facility. So we like breaking stuff and testing it out. As you can see, from the damper itself is going to stay in that opening. That ductwork is breaking off. You'll see the circles that are on there. That weight actually has to be hit within a certain distance of those circles, and it's a really tight tolerance, or else you fail the testing and have to redo it. Luckily, we know how to do some sheet work where we're at. So let's get these, and then. So just, all right, some alternative methods for installation, single side installation for retaining angles. So there's no annular space requirement for single side retaining angle installation. It's the the annular space requirement situation is a bit of a hot topic if you talk to damper nerds, especially people who've done a lot of testing. Really, from our findings, and with a single side installation, it's not really required. It's one of those things that have been passed down on the UL testing requirements that UL requires for two-sided angle installation, and it's never really gone away, even though it's shown not to be to be useful. So basically, annular spaces, if it gets really hot, damper's going to expand, right? But the damper's not going to expand enough in an opening when it gets hot that it will cause it not to function. So on the single sided installation, big thing is at this point, you actually have to have the angle installing or fastened to the opening and the damper. So you want to make sure that it's all there as well. The only downside is the allowable damper size is going to be reduced compared to a two-sided angle installation, and your 3-hour rated damper products will not be allowed to use single-sided angle installation. OFSD or our out-of-wall installations. So big thing with shaft walls is you can't really get at the actuator in the shaft. So what you can do is offset that damper into the shaft, have the actuator inside at a grill or duct connection there. The damper itself is actually wrapped in a thermal blanket. So from a testing perspective, that's how it's going to pass that UL testing. Another option we do have is our 3-sided retaining installation method. A lot of our competitors and we have this as well. The big kind of R&R installation. Sorry, guys. Big thing here is it's easier for the code inspectors to inspect through the elimination of the fire stop material. So all our competitors are going to require fire stop material to be used on the 3-sided angle installation, actually a prescribed amount of caulk. Really all we're going to require is that there's fasteners that are going to be put into that side that's omitted. So you just need to put either fasteners into the wall or the ceiling or floor on the omitted retaining angle side. So we do also have tons of other supplements out there for installation. So if you need to extend a sleeve on one side or both sides, just check our website on our supplements under instruction manuals, and we have all different types of supplements available for that. I just hit on kind of the big, most common ones that we see. So just a quick recap, we kind of talked about the disagreement between UL and IBC on the hourly ratings, our actuation temperature. So we talked about a little bit about with feasibles on that as well. Dynamic versus static, just use dynamic, it makes your life a lot easier. The velocity and pressure ratings on how that impacts damper construction as well. Your mounting orientation, so don't mess up your mounting orientations on your curtain fire dampers. And then I didn't touch on this too much, but the size limitations can be an issue on remodels. So be conscious of that. So if you guys are touching older buildings, especially if it's pre-2005 or 2008, be conscious of the size limitations that could exist between fire dampers. So there was kind of a realignment on the UL side of things for the testing, and the sizing got a lot more strict. So just be conscious of that in the future. Touch on smoke dampers, UL 555S. So these are going to be tested the same as your dynamic fire dampers. The UL leakage classes are kind of pulled from AMCA leakage classes, so they're all the same. Everything is at 4 inches of water gauge. So your class 1 is 8 CFM per square foot, class 2 is 20 CFM per square foot, and then class 3 is 80 CFM per square foot at 4 inches. All of this testing is actually done at an elevated temperature rating of either 250 or 350 degrees. IBC requires smoke dampers to be class 1 or 2 all the time. So what do these leakage classes actually mean? So if you had a 24 by 24 damper at 4 inches of pressure and you had a 3,200 cubic foot space, The length of time it would take to fill that room with smoke is 100 minutes with a class 1 damper and 10 minutes with a class 3 damper. So it kind of gives you an idea of what these leakage classes actually need on that side. So smoke dampers are a lot easier to install, in my opinion, than a fire smoke damper or fire damper. Big thing with installation is that it can be 24 inches of a smoke barrier, and they have to come before any duct outlets. They can be installed directly in the ductwork. We actually, have options that you can have just cut out portion of the duct, slide it in, you're good to go. There's no annular space requirements, and from an actuation standpoint, this is going to be per IBC and more on the fire or smoke side of things, excuse me. But they have to be with the smoke detector within 5 feet of the damper for higher flow systems, or covered with a total coverage smoke system. Smoke damper construction, very similar to a control damper. They're going to have blade and jam seals. They're going to be all multi-blade for the most part. The big difference between smoke damper construction and fire damper construction is we do have some aluminum extruded versions as well. So all actuators must be factory mounted on UL rated products. So that includes fire dampers and fire smoke dampers. We do have options for internal, external actuators. They're always going to be spring return, no matter what. Every single fire smoke damper or fire damper is going to have a spring return actuator. And when we do the testing, the requirements actually that the actuator has 20,000 cycles on it. So that 250 or 350 degree temperature, those heated air testing, the actuator that we have to use to use those for that testing actually has to have 20,000 cycles already on it from UL. So it's pretty strict testing on that regard. Remember, these are all spring return actuators, but we do have 2-position and modulating options available for the dampers and multiple power connections. From GreenHack, we actually no longer offer pneumatic. We just got rid of that recently. So the older buildings and things like that start converting to the electric side of things, because pneumatic is sort of going on by the wayside from a damper perspective. So touch on this before, the 250 or 350 degrees, that's actually an actuator requirement. So that'll come from the actuator manufacturer. And then we abide by that from a testing perspective on our product for UL heated air testing. Obviously, there's a bunch of different actuator torque ratings, and the torque ratings that you're going to see are going to be, in some respects, you're going to think excessive. The reason for that is when we do the torque testing, it's at that elevated temperature where those actuators aren't making much torque. So you'll see on larger assemblies, they're going to have multiple actuators piggyback together. That's the reason for that.
Does that actuator have to be rated at 1900 degrees as well as internal mounting?
Nope, no. So by that point, the damper should be closed already. So it's just 250 or 350 degrees. You're not going to see an instantaneous 1900 degrees on that damper. It's going to, you're going to have an elevated temperature, and by that point, the spring on that actuator is going to close already. Good question. All right, combination fire smoke dampers. So provide the same level of protection as a fire and a smoke damper, just all in one package. So they're UL 555 and UL 555S. I get this question quite often. Can I use a fire smoke damper? Hey, I got a job, fire smoke damper, building envelope change, XYZ, blah, blah, blah. We don't need a smoke damper. Can we just use the installed damper and will that work? Yeah, it'll work fine. It's a UL 555 rated product. As long as that actuator is hooked up, the closure device on the damper itself will close the actuator, and it's always going to be a fire rated damper at that point. All fire smoke dampers are going to be dynamic rated. So kind of touch on this closure device, we use our terminology is RRL, resettable reusable link. It's just a bimetallic disc that'll flip and will cut power to the actuator. We have RL OCI, which is putting an open close indicator on there. So it's just a blade bracket and a little switch and an arm that will go together to give you indication on blade position. We do have our TOR, which has a secondary override for smoke control applications. So the primary is typically your 160 or 250 degree temperature. Once that trips, the damper is going to close. You can have a fire alarm control panel with an override on it that'll open that damper back up for smoke evac or purge, typically used by the fire personnel. And then once it hits that 350 degree temperature, it's going to close that damper permanently. If you have 350 degree air at that fire penetration, your building probably has bigger problems on a smoke issue. So I think you're going to be all right on that regard. We still use fusible links. That is an option. You can still use a fusible link on a fire smoke damper. Typically what we use them now is for failed open operation. So if you think about it, you need your damper to open during a fire. So for a smoke purge application or something along those lines, the damper, once that TOR trips or RL trips, it's going to open that damper. Now, you're in a situation where the fire is at that barrier. How does that damper close and protect that opening? It's a fusible link that closes it. The only way to open it again is actually going to be resetting that fusible link. So once that damper closes, it's closed for good until it's reset. All right. Damper testing inspection. So this is going to be all dictated by NFPA. So, or IFC, which points to NFPA. More specifically, 80 and 105 are going to be on the maintenance side of things. So operational testing. So the big one, NFPA is for fire dampers. 105 is for smoke dampers. They say the same thing, just for their corresponding damper. After installation, the damper has to be tested for operation. Pretty simple. Once the damper is installed, just cycle test it. You're good to go. Big thing here is it doesn't call out use temperature, doesn't use, say heat gun, nothing. Never use heat gun, never use temperature, even on RLs. In our testing, we have seen the quick impact of that heat will damage that bimetallic disc and cause it to not trip at the correct temperature anymore. So don't use temperature. It's not called out NFPA. It's not recommended by any manufacturer. So move forward.
What is recommended by the manufacturer?
You can actually just trip it by hand or just cut power. Either way, it doesn't matter. It's that bimetallic disc. All you have to do is just push it in. As long as you're not punching it, it'll be fine. Or just trip the breaker. You have something like that too. That works. That fulfills the requirement.
You couldn't do that like a hospital setting breaker.
No.
Breaker or anything.
No. But yeah, at that point you just push the bimetallic disc in. So from a frequency perspective, from hospital is a good one. Each damper is going to be tested 1 year after installation. So it doesn't matter if it's a new building, old building. If the damper was installed 1 year after it was put in, you have to be testing it. The testing and inspection frequency after that is going to be every 4 years. And if you have a great lobby, every 6 years, like for hospitals. So big thing too from the periodic testing that we've seen is interesting applications of ways to stop a damper from closing. So in one case, a Dr. Pepper can to stop a blade from closing, or a flammable tube of caulk was another one that we've seen, and then just putting a hole or a tech screw to stop the blade from closing is another thing that we've seen on periodic testings that get caught. Whether it's a nuisance trip or there's a system issue that are causing these dampers to close, it's good to make sure that they are being looked at every now and again, to make sure that everything is functional.
That'll get picked up during acceptance testing. That's the first initial test in the building. If there's a screw in it, you'll pick that up then. It shouldn't happen during an operational test a year later unless somebody was messing around with the.
Yeah, and that's what we see is that, or nuisance tripping, right? For some reason, there's a system issue that, we'll just get this opening and running for now, and then nobody ever goes back to kind of figure out and fix the issue. They can, put a Band-Aid on it and just ran away. The other thing periodic testing, I kind of touched on this as well. For NFPA 80, it just requires removal of fusible link, open, close the damper. You know, test method is for fire smoke dampers or smoke dampers is just visual confirmation of the damper. So sticking your head in the duct, making sure it's closed. Like I said, no heat on the heat response devices, anything like that. 2019 edition of NFPA now allows remote testing. So that's a big one. That is potentially a game changer, especially on the hospital setting, where you are allowed to use the damper position indication as a means of confirming the damper working. All right, so we kind of beat this one a little bit here, but the OCI indicator on the blade, you know, that's going to be where it's required a lot of times in California, for example. They don't allow any auxiliary switches to be used for damper blade position. Their argument there is that the actuator could slip and a misindication of open or close. So that they require all OCIs. You can see that actually being adopted now across the board on that side of things. Touch on this a little bit. Modulating fire smoke actuators. This has been one that has picked up in recent years quite heavily. They actually are being used as balancing applications. So getting rid of balancing dampers and further obstructions in the ductwork, lower the pressure drop. Same as any other balancing actuator. You know, 0 to 10, 2 to 10, 4 to 20 milliamp can be controlled. We do have on our FSD 211 quote unquote balancing option. And that will include a Blemo SGA 24 potentiometer with it as a factory option. So you can order them all set up, ready to go to be used in the balancing applications. So helps circumvent the AHJ asking questions. You can say, hey, this comes from Green Tech as an option. So momentary test switch, probably our most popular option that's chosen on the dampers. It's just going to be, you know, press the button in, stick your head in the duct, make sure the damper closes. Once you release it, it'll start opening again. Remote test panels, wall mounted test panels, so go right onto a junction box. We have a few different configurations. All of them are going to have a position indication, and then you know, depending on what model you're looking for, have either a momentary switch, a toggle switch, or even a key option that we use specifically for our TOR, where it's an override. Factory mounted and wired smoke detectors. So we do have that option as well. If you want to get your all-in-one damper, you know, set up, ready to go with a factory mounted and wired smoke detector, we do have that option available. We have, you know, our what we call a low flow, which is used as a flow sampling smoke detector, and our no flow option as well. They are not addressable though. So we don't have any addressable options on that side of things. Becoming more popular here, but out east, something we're seeing a ton of is the automatic balancing dampers. I'm not sure if you guys are seeing those come into use a lot more, the ABD style dampers. You know, so we call it ABD FD. It's a fire damper and a automatic balancing damper all in one. Big thing with automatic balancing dampers is it really helps to, you know, with stack effect and making sure that, you know, each floor is getting the appropriate CFM, or each building or room in that is getting appropriate CFM. Factory mounted accessories. So like I said, we can kind of do it all. If you just want a plug and play damper, we can include factory retaining angles. We include, you know, quick connect breakaway connections, as well as access doors all in one damper. We touched on it too. We can include giving a smoke detector on there too. So if you need a quick option on that side, I think we can make it happen. For folks that are using the Revit side of things, we are building a pretty big library right now for, we focus on our life safety stuff for the time being, but we actually have actuator and junction box locations on the Revit content now. So from a space envelope and connection point standpoint, it can be all configured in the building side of things. So there's no guesswork anymore. It's all there. It's all available. All right. Any questions on the life safety stuff? I ripped through that pretty quick.
damper with the single retaining angle on one, or the retaining angle on one side. Is the installation what's certified to be approved for that, or is the damper assembly, is that what has to be certified for that, approved for that installation?
Both, actually.
Okay.
So it's mostly the installation, but the damper has to be, and that's where the size requirement comes in. So on the slide, and something I mentioned is that there's a reduced sizing, and that's because of the damper assembly size.
Okay, so smaller is better.
Not well.
I mean,
Yeah,
it gets to be too big, that's where they're gonna say you need one on both sides.
Yeah, and I think we can go to like 144 by, what is it, 96?
Oh, that's pretty big.
So you know, you can still go pretty darn big. But like I said, if it's a 3-hour rated damper, it has to be 2-sided at that point. So, but there's, you know, if it exceeds a certain height or a certain width, so there's
Multiple factors.
yeah, but for the most part, 90% of the dampers that are installed can be used single-sided retaining angle. But 90% of the dampers we sell should say that you can use that single-sided retaining. Yeah. So we'll totally shift gears here to industrial dampers. So on the industrial side of things, I do dabble quite a bit in the industrial side. You know, my focus, like I said, is more on the commercial, but I do have quite a bit of experience with our industrial dampers. On the Green Hex side, Bill Lampkin and Eric Kaler are our 2 industrial guys there, but I do fill in every now and again for them. So big thing on industrial dampers, you know, commercial, we're looking at 6 to 10 inches of pressure, you know, 8,000 feet per minute is going to be kind of a high velocity for us. And 250 degrees, that's a high temperature on the commercial side. You know, pressure's up to 45 inches and temperatures up to 1,000 degrees, not a problem on the industrial side of dampers. So larger sizes, especially in the round, commercial dampers top out 24 inches round. We can go up to 72 inches. Well, actually 96 inches now on our round stuff. And you know, we can fabricate that all in house. Up to 120 by 96 on rectangular. Like I said, we do larger with special designs. You know, touching on the special design request side of things, our industrial heavy duty damper team is more built like a fab shop, where our commercial team or commercial is more of an assembly line type operation. So what that means is that on an SDR side of things, it's a lot easier for us to do an SDR on our heavy duty stuff, and we do that a lot more than we do on our commercial side of things. No AMCA certifications on our industrial stuff. From a marketing standpoint, it doesn't pay. Long story short, you know, with our commercial stuff, you know, any control damper we sell now, if it doesn't have an AMCA sticker on it, we have a hard time, you know, meeting spec. But on the industrial side of things, AMCA is a lot less of an item to contend with. And the big thing there is going to be other certifications. So we do a lot of custom testing for seismic. That's a big one, as well as blast. So we do a lot of dampers for Marinette for Marine. And that's going to be a lot of blast dampers and things that have to meet certain military requirements. So we do test on site for specific testing requirements, as well as for seismic on tunnel jobs as well. So rectangular control dampers, we have 10 standard models. So commercial side of things, we have half that. Where the big thing on rectangular control dampers is, we have to have a lot more options available for specific applications. So these are more geared toward process and manufacturing, whereas commercial stuff is going to fit into more of a smaller building side of things. Like I said, I touched on 45 inches max pressure, 6,000 feet per minute is actually on the low range for some of the rectangular control dampers. Something I want to touch on, the reason why is a big thing is the bearings. The bearings and the axles. So, and the heavy duty side of things, A lot of it's going to be full length axles on control dampers for commercial. You're going to see, stub shafts that are being used for the most part. Lot heavier duty bearings are going to be used. So this is just a typical O-ring shaft seal. This is going to be the lightest weight option, which is still quite a bit heavier than what we use on the commercial side of things. And then it goes up from there. So we got double gland shaft seals as well as I missed the slide. Well, and then we also do have other options on that side of things too. Probably our most popular model that we see used on the heavy duty side of things is our bubble tight dampers. So these are zero leakage, full isolation dampers. They were, they're bubble tight up to 10 inches of pressure and can be used up to, almost 4,000 feet per minute on our HVTR or 151, and then 30 inches and 6,500 feet per minute on our HVTR 451. A lot of applications we see these being used in are going to be embassies, post offices actually all have to have isolation dampers, and mail rooms for anthrax, the whole thing back in 2001. Every damper that is bubble tight has to be factory tested per AMCA standard 500D. It is tested to standard 500D, but it does not bear the AMCA label on that. But like I said, it's every damper has to be tested before it leaves. Isolation dampers are similar to our bubble tight dampers, but they are ultra low leakage. So like I said, these are models that we're seeing a lot of application and growth into. So before I do that, so like I said, on the heavy duty side of things, we're going to see a lot more of special design. So temperature is a big one we see for special design on heavy duty stuff. So higher temperatures, think of around here paper mill applications we see a lot for high temp and different types of materials. So if you have silicone free, for example, or it has to be 316L stainless, for a hospital application, that's where we'd see a lot of that come into play. Ron, any questions at all? Pretty quiet group.
That means it was thorough.
Yeah.
Hopefully I didn't put a damper on your day.
Thank you, Sean. If I could have the other presenters, Colby and Joe, come on out, that'd be great. Get you parting gifts. Sean, I don't know if you've heard the field, but thank you from us to you. The holiday cheer, we're a little early, but thanks to those who presented. Thanks to you all for attending. Any questions about the presentation at all in general for me or for the group? So there'll be a follow-up survey. Those are really helpful for us, especially as we get new people in new positions here at Webb. Be on the lookout in the next couple of weeks for the email shift, and then Q1 of 22 for the website. Again, I don't anticipate it having much of an impact on this group. You can always send stuff right to me as well. But we're thrilled to have you. Big thanks to our board as well. Dave and Andy and Matt, and Dan is not here, and Phil, right?
Big thanks to you and your staff for
Thank
putting
you.
this together.
Yeah, thanks for being patient with us as we kind of shifted dates around, and we got it in though. So thank you. You had a question?
Are you going to be available online or on the learning center?
It's going to be available. We got to find a way to put it through the sausage maker and get it on YouTube. It shouldn't take that long, but it's a huge file, right? It's 6 hours of video. So we'll put it on YouTube and we'll share it with you all. It'll be kind of link, not protected, but if you have the link, you can watch it. You can forward it to people if you want. I was joking with Luciano. I don't know who else is going to want to watch this except people in our industry, but hey, they're more than welcome. But anyways, any other questions? All right, well, thanks again. Continue to be involved and engaged. Get your stuff up on Certelligence. Reach out to us if you have questions. If you want to reach out to National, you can do that too, but copy me. It's just helpful to know what's going on. Gifts for the rest of you. Another round of applause for our presenters. And lastly, if you did not sign the sheet, please do. Dave Wittig, if I could just get you to re-sign this because you're the only one on sheet 2 and then it's all together. Because without this and without your certificates that are waiting out there, you were never here and this never happened. And we want to make sure you get credit. Nope, just once. We're only doing once this year because everyone is here for the full program. And then leave your name tags with Bree. She's up at the front as well. So thank you, everyone.
You can time stamp it too.
Well, but you and Luciano don't need any credits for anything, right?
You should find out. Oh, okay.
Thank you.